Good day, guys. Welcome back to the King tutorial class. In our last class, we looked at probability, under which we looked at the definition of probability, we looked at the formula related to probability, and we looked at experimental probability, and we solved questions under it. In this class, we're looking at theoretical probability. Theoretical probability is the probability of an event based on equally likely outcomes. Theoretical probabilities are exact values and they can be calculated. For example, if you toss a coin, you get two possible outcomes, head or tail. Since both outcomes are equally likely, the theoretical probability of getting a tail is what? 1 over 2. Why? Because we have two faces of a coin containing what? The head or the tail. So the likelihood of the head coming out is certain, and also the likelihood of the tail coming out is also what? Certain. So the probability of getting a tail is what? 1 over 2, similar to head. Similarly, if you throw a die, the theoretical probability of obtaining any number is 1 over 6. Okay, the probability of getting any number is what? 1 over 6. Probability of an event happening or not happening. If E represents a particular event, the probability of E happening is written as P of E. That's probability of E, probability of the event in that case. And it always lies between 0 and 1. That is 0 less than or equals to P of E less than or equals to 1. The probability that the event E does not happen is noted by P of E prime. Hence, P of E prime is equals to what? 1 minus P of E. Example 1. A fair die is thrown. Find the probability of getting A 5, B, an even number, C, a 3 or a 4, D, not an even number. In this case, we have to get our sample space, which is represented with what? S. And our S is equals to 1, 2, 3, 4, 5, 6. Why? Because a fair die contains what? 6 faces. Total number of outcome is what? 6. For question A, the probability of getting a 5 is what? 1. Okay, on a die, you see 5 how many times? Just once. So in that case, probability of getting a 5, which is P of 5, is equals to what? 1 over 6. For B, probability of an even number is 3 over 6, which is equals to 1 over 2, where the even numbers are what? 2, 4, and 6. Question C, a 3 or a 4. In this case, you get 3 once, you get 4 once, which becomes what? 2 over 6. Or probability of 3, which is 1 over 6, plus probability of 4, which is also 1 over 6. That becomes what? 2 over 6. And for D, not an even number, in that case, it's also going to be what? 3 over 6, because if it is not even, it's going to be odd. And the odd numbers there are what? 1, 3, 5. Using set notation, probability can be described in set language. For example, if P of A is the probability of an event happening, then P of A equals to what? Number of A over number of what? S. That's number of sample space, where A is the what? Required outcome, and S is all possible outcomes. Example, the table below shows the number of students in each age group in a class. It shows the number of students in each age group in a class. What to find probability that the student chosen at random is A 14 years old, B at least 15 years old, and C lies between 14 and 15 years inclusive. Solution. Total number of students in the class is what? N of S. That's the number of the sample space, which is what? N of S equals what? 5 plus 15 plus 16 plus 4, which gives us 40. For question A, let A represent 14 years. That becomes what? Probability of A equals what? Number of A over number of what? Sample space, as expressed earlier, which gives us what? 15 over 40, and leaves our answer with what? 3 over 8. B, let B be equals to what? At least 15 years. That is, N of B equals what? 16 plus 4. At least 15 years in that case means 15 above. So that becomes what? 15 and 16 in terms of years. So number of students of those 15 and 16 ages is what? 16 and 4, which becomes what? 16 plus 4 then gives the answer to what? 20. Therefore, probability of B equals what? N of B over N of S, which is equals to what? 20 over 40, which is equals to also what? 1 over 2. C. Let's see B equals to what? The ages that lie between 14 and 15 years, inclusive. So 14 and 15 years inclusive means you have to add 14 years together with 15 years and together with any age that is in between 14 and 15. So looking at the number of students under these ages, we have that what? 15 and 16, which becomes number of C equals what? 15 plus 16 equals 31. In that case, we have our answer to what? 31 over 4. We want to find the probability of C.